let's take a look at how to find the measure of an angle. The first thing we need to know is that there are a few conventions that we have. First of all, this positive x-axis is what we call our standard position for angles. So this is where your initial side is going to be for any angle that starts in standard position. And it makes sense because that's where it starts on our unit circle. And if you look through your unit circle, you'll notice that as you start here and go counterclockwise around it, you end up with positive angles. And that's not just arbitrary. It turns out that also follows our coordinates, our quadrants for the coordinate plane. Quadrant 1, Quadrant 2, Quadrant 3, and Quadrant 4 follow that same idea of counterclockwise being positive. So if counterclockwise is positive, and we have to have a negative, makes sense that it would be clockwise. So our first thing that we need to know about finding the measure of an angle is that any angle that spins counterclockwise is going to be a positive angle, and any angle that spins clockwise is going to be a negative angle. So as we're going through a couple of these practice problems, if you notice that an angle is spinning counterclockwise, you know right off the bat you're going to end up with a positive angle, and if you notice that it's spinning clockwise, you're going to end up with a negative angle. So let's take a look at a few examples. Our first one, our goal is to find the angle that the red arrow goes through. So I'm going to work through this in green. And typically the one thing that people recognize is that each quadrant is 90 degrees. So we can start by going ahead and putting 90 degrees off to the side. We're keeping track of all the angle that we're going through. And since we recognize we've gone through one quadrant, from here to here is 90 degrees. In order to figure out the rest of the angle, we need to know this right here. And luckily, we were given that angle. So all we have to do is add together those components that we made it up, and we've got 130 degrees. And again, because we're going counterclockwise, we know that we've got positive 90, positive 40, which gives us positive 130. So this first one's a little bit straightforward. You're just adding as you're going through those different quadrants. So let's take a look at one that's not exactly so easy. Here we've got a much larger angle as we go through. So we can still break it up into 90 degrees for the first quadrant, 90 degrees for the second, 90 degrees for the third. But you can tell that's going to get pretty tedious as we go through. So what some of you may recognize is you can count this whole angle here as being 270 degrees. If you think about your unit circle from starting in standard position all the way to down here is 270 degrees. Well, now we've got to figure out what this angle is that we go through. And this ends up being a little bit tougher because before they gave us this angle, but now they tell us this angle right here, 37 degrees. But we know that every single quadrant is 90 degrees. We covered that on the last problem. So our goal is to say, all right, what plus 37 degrees gives us that 90 degrees? So really, we've created an algebra problem here, where instead of a question mark, we can say x. And if we do just a little bit of math to get through there, we can actually figure out what that angle is going to be. So if we go through and we take 90 degrees and we subtract 37 degrees from it, we end up with 53 degrees that's left over. So that means in order to make this whole quadrant 90 degrees, this angle has to be 53 degrees. So we spin positive 270, another positive 53, and we end up adding it all together to get 323 degree angle. If you're not comfortable with that 270, you're more than welcome to break it down into all of your 90 degree angles, or even into a 180 and a 90, and then the 53. If you take 180 degrees, add one more quadrant, and then add your 53, you'll still end up with 323 degrees. But it turns out with this, if you're really thinking about it, you can find an alternate way to do this. Some people may recognize that you're really close to a full circle. And if you know that a full circle is 360 degrees, then all you have to do is take away 37. because you're almost at a full circle, you only need 37 more. So taking 360 degrees and subtracting that 37 will still get you 323 degrees. There's a lot of different ways to go through here, and all that matters is that you make sure that you're keeping track of how you decide to solve it. I find most people are comfortable by adding 180, then 90, then their 53 that's left over, but if you can find a better way to do it, that's totally fine, as long as you figure out the angle of that red, or sorry, the measure of that red angle. So the last thing that I'll tend to do is I'll make sure that my answer makes sense. If you know your unit circle, then you know that down here is 270 degrees, and up here is 360 degrees. Our angle should fall somewhere between 270 and 360. And since 323 is between those two, I know that I'm more likely to be correct. If I end up getting that I have a 600 degree angle, then I know that this one angle right here can't be 600 degrees. It has to go through, it's less than a full circle, so my answer has to be less than 360. Let's take a look at just a few more practice problems. First one is our first foray into negative angles. So just like last time, we're not given what angle we go through, we're given what's left over until we get to that 90 degrees. So doing a little bit of math as we go through, we can see that in order to get that 90 degrees, we have to do 20 degrees plus something else, and a little bit of algebra will tell us that something else is 70 degrees. But I can't just put down 70 degrees, because we didn't travel 70 degrees. 70 degrees would be a counterclockwise angle. We're going clockwise, so we need to make sure that we say it's negative 70 degrees. Without that negative, this angle would be spinning counterclockwise. So again, make sure any angle that you have going clockwise is going to be negative. This one looks very similar to the first one that we did, but it just takes longer to get there. So in the first one, we started at standard position, we went through quadrant 1 and straight to the end. But this time, our starting position is down here. We're going to go through one full circle before we start to go through. So I'm going to go ahead and make a little note to myself. I went through one positive full circle. Now I'm going to travel that 90 degrees. And then I travel that last 40 degrees. And I end up with an angle of 490 degrees. So the number of times you spin definitely makes a difference on things. This one, again, is very, very similar to our first one. Let me see if I can back up to it. Same exact angle, but on the new one, we went around a full circle before we went to that last angle. So that's one thing to be careful of. Around this time, you should start getting a hang for it. So what I encourage you to do is try this one by pausing the video and then coming back to it. So I'm going to give you guys a second to pause it. So hopefully you guys paused it and tried out the problem. Let's see how you did. So we start here and we go around one time. I'm going to go ahead and make a note of 360 degrees. But if you notice, we're going clockwise around the circle. So I should have negative 360 on my page. Now I go around another full circle. So I'm going to go ahead and take away another one. Now I recognize that I'm making 180 degrees. So I'm going to go ahead and take away another 180 degrees. And last but not least, I need to figure out what this angle is right here. So if I know that the whole thing is 90 degrees, they give me 52 degrees of it, I need to figure out what that last angle is. So I'm going to take 90 degrees and I'm going to subtract 52 from it, and I end up with 38 degrees as the angle we go through. But since I'm going clockwise, I need to make sure negative 38 degrees. Add all these up, and if you came out to get 938 degrees, then I feel like you should have a pretty good hang of this.